But maybe with a little practice, I could tell myself to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too dark, wake up, my love. Please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? Oh my, it's been a while since I've seen y'all's beautiful, beautiful faces. Let's go ahead and stop this hype music. And let's start this chill music, shall we? How you guys been? How's Taylor been treating all y'all? Let me pull him in here. Where are you, Taylor? Say hi, Taylor. Taylor? I think he died.
Hey, you guys.
Oh, there he goes. Can you say something else?
Yeah, absolutely. So I'll be here on standby to help Elijah with the following module for this week.
Perfect, perfect. Yeah, I'm just, can you guys hear him just fine? Just want to make sure the audio is coming through. But, it's nice to be back. It's nice to see you guys. Hopefully, things were really great with Taylor. You guys were fairly entertained, and things didn't go too awry while I was gone, right? No? Maybe a little bit? Sweet, sweet. Well, let's do our whole rap thing first. Hey, we're a rootkit nonprofit here in the US of A. We're doing 100 days of rootkit where we're teaching for 100 days items that are on our certification exam. That's our comp sci certification exam, complete replacement to college. Get that, we'll help you with the job. It's guaranteed if you're in the US. If you're not in the US, not 100% guaranteed because we don't have connections right now with any international companies, but we will try every last thing we can do to get you a job, and we're pretty much like 99.9999% confident. Don't worry. Now, see this beautiful shirt I got? Look at this. So beautiful. You can get that shirt by donating and having that, there we go, that bar up there go up. Also, we got our sweaters in. I would wear this, but I was washing it and it's still a little wet. So we got our sweaters in, and it says Rootkit on the back. They're super awesome, very, very thick. They are definitely heavy duty, and the inside of them is pretty soft. They will help keep you warm through most places winters. Maybe if you're in the middle of nowhere where it gets like negative 10 degrees, you might want something else on, but that will help you throughout just about everything else. So again, we're streaming to raise money. All right, our goal is 25K, and we have a generous donor who is matching all contributions up to 10,000, and they will be cashing in their donations at the end of every month. So let's get this going, get this up. If you donate on here, this is where you can get the stickers, you can have me dance, you can get the shirt, and I will be adding the sweater on there for those of you who are interested in getting the sweater. Alright, and we have these little, what do you call it, benchmarks that we want to get to here, where you'll see me do various things like teach for 24 hours straight. I will not sleep. I will be here going at it, teaching anyone that comes along, maybe doing some programming, who knows, 24 hours, maybe you'll see me go a little delirious. It'll be fun, alright? If for some reason you don't want to see this bar go up and claim some merch here, you can come over to our site and come over to our store. I don't know why the little icons are messed up, and purchase some items here. Also, if you want to continuously support us, we have Patreon and we have Discord Premium, which you can subscribe to right now. They're linked in the descriptions if you're watching on YouTube. If you're not watching on YouTube and you're watching on Twitch, I mean, come on, you're watching on Twitch, man. Get with the YouTube program. Just let Google take over your life. That's what they're trying to do, all right? Just accept it, all right? That's what I've done, all right? Now I got Google everything. And they are my overlords. They're listening, all right? We don't want to make them mad. Mostly because we don't want to get banned anywhere. But let's see here. Discord is on our site here. Also, if you have no monies, good, come. We have our week 2 giveaway just ended, which means we're giving away some merch today. Also, even better news for you guys, the three that were emailed on week 1 for their merch did not claim their prizes, which means we are re-rolling them today, and 3 new people will get the opportunity to claim the merch. All right, and we have week 3 out. Week 3, we're giving away one of these sweaters. All right, so if you want one of these sweaters, go ahead and fill this out. It is 100% free. Collect your points. It is online. It is running now. All right. Sweet, sweet, sweet. I think I covered just about everything. Am I missing anything, Taylor?
No, I don't think so. That's pretty much everything about us. The only thing that I always covered every day is the fact that we have our FAQs on our 100 Days of Root kit, where we try and answer any popular question, and we can always add to it if there's others.
That's right. We have that. And then also, I should say, at the end of almost every stream, we do handouts. They're called our companion guides, and those are given to all of our Discord Premium and Patreon members. So subscribe to those if you want to get those handouts. They are super awesome. Let me see if I can pull up. We posted day 1 for free on the Discord, and so it's pretty much just a review of what we talked about, maybe some flashcards if one of you awesome people make flashcards. So Wolf made the awesome flashcards here, and then we have some questions that we'll give you, and at the very bottom we'll have the answers to those questions. We also link videos that may help you in learning what you're trying to learn. Awesome, awesome, awesome. So today, kind of up to you guys. So last week I said every Saturday would be our chill, roll it back, let's review, talk about stuff that you guys went over in the week day. Now, after a little bit of reflection, we realized that a lot of people may want Sunday to be their chill day, so that way they can mentally prepare for work on Monday. So it's up to you guys right now whether we change it to Sunday or we keep it for today. So it's up to you guys on how you want to do your review stuff. So if we want to do review stuff tomorrow, we'll do the review stuff tomorrow. If not, and we'll get into networking today. Sorry, that was a struggle to get through. So it's up to you guys. Do you want to start on networking today and keep chugging forward for today and then do review tomorrow, or do review today and start networking tomorrow? Give you all a second to respond in the chat. Let's see here. I'm just looking at the Discord right now. Yeah, so to join the Discord, you can go right here and go ahead and click on that Join Discord button on our website. Come on, I need to know what you guys want to do. Review Sunday sounds good. I got someone voting for Sunday right now. Does anyone want to rebuke or rebuttal, or are those the right words? Basically challenge that. Anyone opposed to doing that? Or I got more agreements. All right, sweet. All right, let's do that. That might have been a wiser choice. Look, we're the streaming stuff like this. Hey, we're kind of just doing it on a limb. Some of the items here. So again, we're all about community in our nonprofit. We're about openness, and we want to not just be the people that say it how it is. All right, it's all about what we want to do collectively and how we want to progress and what needs to be done. And you know, we're all about making champions, aka what we call our volunteers, and giving anyone the materials they need to be in order to be an awesome champion and help with the progression of this charity. So I see everyone is interested in Sunday, so let's go ahead and do that. We are getting into networking. Let me, do I need this? I'll keep this off to the side right now. Networking. Oh man, networking. Some of the most common questions that you'll get when you have a interview with a company that is comparable, is that the right word? An actual challenging interviewing process. Networking and memory are the two main questions they'll ask you. Just general networking topics, and generally, like memory, they'll ask you about the stack and the heap and how those work. And then they'll ask you about networking, which we're about to go over. They are pretty common amongst the more robust interviewing processes, because I would say maybe like 30 to 20% of them are more robust, where they'll ask you a bunch of challenging questions, and the other ones are more going to be like very job specific. They don't really care about the broader like concepts. So let's see here. At all parts of life, networking is important, whether it's actual networking with human beings, talking to people, communicating, getting new relations set up, maintaining those, or networking when it comes to the computer level on how they talk and communicate. It's always super, super important. Never lack on your networking knowledge. It's one of the most important things that you need to know, because it can be potentially the most laggiest part of your applications. And there's not too much to a certain extent that you can do to minimize it to a really small threshold. For example, if I'm hosting a website and it's in the US and you're living in a different country, let's say in Australia, there is an actual physical distance between us. So no matter how optimized I have my server, there's always going to be some sort of lag or latency between when someone in Australia goes to my website and when it will respond. And there's nothing you can do. You can make your site the most optimized, beautiful piece of software ever, but it doesn't matter at the end of the day, because there's physical distance, and data can only travel at max the speed of light, which most data that's traveling across continents is going to speed of light. We'll get into the difference between copper and fiber and stuff like that here in this lesson in a little bit, but that is the main slowdown potentially. But let's talk about other concepts or things that you can do with networking. Where is it at? Here we go. So what are some things that you do every day with networking? You guys list some items down. Just networking in general. They could be for computer science, or they can be actually with computers, what you do with computers over the network of computers. Can anyone list some things that you do on like a regular daily basis? Because you do a lot. Pretty much all of us live on the internet. Let's check the chats here. Social media, Google. There we go. Those are some awesome ones. I mean, yeah, you guys are right here watching these YouTube videos. Now, just like networking in real life, it requires people, in real life, it requires you and someone else to communicate with each other. But it's not as simple as just communicating with each other. You have to at least be speaking the same language in order to communicate effectively, correct? So that's also an issue in computers, is they have to be speaking the same language when they are communicating, or else they just won't be able to communicate at all. So that is something you will see that comes up while we go through these lessons on how it's important to make sure everyone's on the same page, talking to each other, because you don't want the computers to be a little bit confused. But file sharing, mail, photo sharing, YouTube, playing your video games are all part of computer networking. Most people refer to networking as the internet. That is a part of computer networking, but it is not the only part of computer networking. And we'll get into that a little bit later. There's actually lots and lots of networks that are out there. So let's see. Let's get a cool computer networking graphic up here. Let's see which one. Do I like that one? I don't know. Let's go with this one. I like this one. I'm gonna get this on a new image. There we go. So the thing in networking, in computer networking, is you'll hear these terms called nodes. Nodes or hosts be thrown around, and effectively those are just aliases for computers. Also, you hear things like servers. Servers are also just computers. Your normal computer in front of you can be a server. It's just some software that you install in order to allow other people to communicate with your computer. There's nothing fancy, no special hardware you need. Your phone could be a computer. A server. Almost anything that you have can be a server that connects and talks to other people. And usually in networking, these are going to be called nodes or potentially hosts. So every single one of these circles that you see on these graphics would be things we would refer to as nodes. And the lines connecting them would be physical cables that connect the nodes together with each other in order to form a network. So let's see here. If you guys have any questions while we go through this, go ahead and ask them. So, a communication channels provide a connection between computers. So, you need communication channels between computers in order to make connections where they can send data to each other. This can be done, like I said, with actual cables. You can use fiber optic cables, you could use telephone lines, you could use wireless technologies, even light itself, like light bulb lights. Anything that can transmit potentially binary data, aka being in an on or off state, can be used to translate data from a computer to another computer somewhere else. You just need the proper adapters for it. Those are usually called network adapters. So that's another key term, is network adapters. You will need in order to grab data from a wire and put it into the computer so it can actually talk to your computer instance. So there are various things out there. Like I said, wire cables, fiber optics. Fiber optics are usually going to be for beefier connections, but most commonly you'll be accustomed to like your Ethernet cable, which will be let's pull up a good picture of your Ethernet cable. It will look like this guy right here. And this is the most common way you'll connect your computer to, let me zoom in, your computer to the network. Now, I mean, wireless is also a potential way, and let's see here. There's also cell phones that can communicate over radio frequencies, and there's actual like radios. So there's this thing in networking called protocols. All right, very key term. So we got nodes, hosts. All right, those are important key terms there. And another one is going to be your network adapter. It's what allows you to communicate over a network. Right? It's the interface between your computer and the wires you want to communicate across. Protocols is going to be the next thing. So what is protocols? It's a fancy term for something you do every day in a million different ways. For example, you want to drive your car. There's steps you have to perform to get into your car. Then there's steps you have to perform to drive your car. On the road, there are rules that you have to follow. Those are all protocols that you have to take. They're rules that dictate how you should be going about something. So that's what protocols are at the end of the day. They are a set of rules that allow you to communicate properly. So in computer science, it would be it would be a set of rules that allow computers to establish and maintain a useful communication at various levels. Because just like when we start a sentence with each other or we want to greet each other, usually we'll say hello, and you might say hello back, and then we'll start with our chatting. Computers have to do the same thing effectively in order to talk to each other, because at the end of the day, how do computers talk to each other? We know there has to be binary in it, but even if there is binary, how do they know who talks when? You can't just all shoot off at the exact same time like magic. It would be too congested. It would be like if both of us were yelling over each other. It wouldn't be very effective. Maybe we get a piece of information from through all the noise, but it just wouldn't work out very well. So we have to follow protocols, basically customs and courtesies, if you want to think of it like that, on how we'll go about talking to each other. So that's another thing, is all networks will have downtime in the sense that there's nothing being sent, or they're all communicating one at a time with each other. It's not this magical thing where thousand communications are happening at the same time. So in today's world, an operating system includes services that support networking. A networking operating system is a specialized operating system for a networking device such as a router, switch, and firewalls. We're going to be getting into those bad boys also. You'll probably be very familiar with something called a router. This is the bad boy that you either love or you hate, right? It either works great for you, or you constantly think about getting a new one because it's not doing what it needs to do. I'm gonna go and check chat real quick. Make sure there's no questions. Now, routers are computers also, and switches are computers, and firewalls are going to be computers, and they all have a very specific purpose in securing your network. They're kind of moderators. They're the middleman. To try to help sort out all of the craziness that's going on. And they all have their own specific operating system on each one of them. They're not running, Windows. Some of them maybe are running Windows. An operating system at the end of the day. It's the software that goes onto it. But more and more, they'll usually have custom operating systems, or they'll be using Linux. We'll get into what Linux is more in our operating systems class. But these are important key pieces of software for communicating, and we'll get into each one of them a little bit more specifically here in a second. So let's pull up the rootkit guide right here for networking protocols. All right, so if you're going through this by yourself, you'll see the first thing here is TCP/IP. We'll get into that in a second. Next is protocols, which we covered. That's just rules on how you go about communicating. We got our network adapters, which is how you will interface with the wires that you plug into your computer to communicate over a network. TCP/IP is one of the most important aspects to communicating over the network. So in the beginning days of computer networking, there was no overlying standard for networking communications. So each individual company established their own proprietary way of allowing computers to communicate with each other. So every company in the early days of the networking space, I don't want to say internet, so this is going to be what, 70s to 80s, kind of in the 60s. They were all, no, it even went into quite recently, I think the early 2000s. Every single manufacturer, if you bought an Apple computer, if you bought a Windows computer, if you bought certain types of hardware from IBM or so forth, they would make up their own language effectively on how you could talk to other computers. And as you can imagine, it was an absolute mess. It was crazy. It was just frustrating for consumers because you might want to network with someone else, but you can't because you don't have the right hardware. And at this point in time in history, everything was $1,000 plus in the computer space. So it's very, very expensive, very, very frustrating. So consumers were fed up, so the companies finally got together and they said, all right, let's stop this nonsense and let's make some standards that we adhere to. All right, we talked about standards in earlier weeks in regards to data layout and IEEE and why they were stood up, because data at a fundamental level on your computer is just data. It's arbitrary. It's just ones and zeros. It's on you on how you want to interpret it. So everyone was interpreted differently. IEEE came around to set up standards on how you should interpret it. So now most people follow IEEE. So that way it's predictable on how you understand data. Same thing came around for TCP/IP. So let's see here. IPX and SPX was developed and used by Novella, Apple, and AppleTalk was the standard for Apple Mac computers. So if you wanted to talk with Mac computers, you would have to use AppleTalk. IBM used SNA. That was their own protocol. Then, shortly after, the TCP/IP protocol suite became the internet standard and replaced all older models. The emergence finally allowed computers from different vendors to communicate with one another. So this was very, very revolutionary, because now you didn't have to deal with all that mess and burdensome stuff. But don't be fooled. Just because it's the agreed upon standard doesn't mean you have to use it. You can invent your own communication methods with computers. It's all, again, data at the end of the day, and data is arbitrary. This is just the established, guide of how you should go about it. But there is no regulations federally enforced by the UN anywhere that says this is law and this is how you should go about it. It is wild, wild west. It is the wild, wild west in the computer software realm. There is no codes like building codes and stuff like that when it comes to software. It is very much arbitrary in what everyone is agreeing to. So if you want to be a rebel, you don't need to use that. Or maybe you want to do something that's more malicious. Maybe you want to hide some of your traffic or what you're trying to do. There's nothing stopping you from creating, inventing your own communication protocol and using that as the de facto standard between you and other computers that you want to talk to. All right. Any questions on that so far? We covered a lot of general stuff right there. Anything you want to add, Taylor?
Sure. So, although we can make our own protocols and our own functionality, so you can create your own router, which handles your custom protocol, but the issue with doing stuff like that is, let's say that we're running an assembly line on a factory, and we want our communication to be really lightweight and really fast, so we don't want to use UDP, or we don't want to use TCP, but we want something heavier than UDP, so we make our own protocol in the middle, and everything in our factory communicates over that protocol. If we ever try and route out of our network to the internet, the first router that we meet is going to deny us, because it cannot speak our language. It will have no idea what we're saying, and it's probably going to drop it, or maybe send it back, if we're lucky. So it's very dangerous making your own protocol in the fact of functionality. You may expect things to work a certain way, but then you hit a router that you don't own, and everything breaks. So it's very important to know that you are making a custom protocol and what you expect out of it.
Yep. Yeah, and you'll see there's a common technique of wrapping, and we'll be going over lots of protocols that are in protocols, that will do wrapping in order to bypass some of those limitations. I don't see any questions, so we're going to keep chugging along. Next item's on here. Very, very important. Very, very important is your local area network. And then we have the wide area network. These two pieces are pretty similar, but also very, very different. If we go on and look it up, your local area network, you'll get some nice pictures that show up and definitions that show up. The big thing and the big keyword here is local. So this is going to be local, close to you, wherever you currently are. Are you in a house? Then everything connected to your router is going to be your local network, your local area network. It's basically a mini version of the internet. You can directly communicate with other devices in a local network without ever having to go out to the internet. If you were to cancel your internet plan and host your own server in your house, you could view that server on your phone or on another computer because it's on your local network. It's all being controlled by your router, which routes traffic, and we'll get more into that here in a bit. Now, your wide area network, your WAN, is going to be the internet. It's going to be out wide. It's going to be everything you can pretty much reach out to as wide as possible. So that's pretty much the internet as you think of. You can communicate with anything else that's publicly available. Anything you want to add there, Taylor?
So we talked about these yesterday, actually, but in terms of wireless technology. And we went over like what a WWAN is or a WLAN. So these are the exact same technologies being implemented, except where we dealt with yesterday wireless communications. Today we're dealing with physical or wireless communications. It's irrelevant to us at this level on how it's connected.
Yep. So next we have peer-to-peer. Also important, not used as much, but it's always very popular amongst people that are anti-establishment and so forth, because it allows you to effectively have your own private internet that potentially spans through the internet. If you ever go to, let's see, if you ever load up like Tor and you go onto the Onion network, that's going to be a peer-to-peer communicating network because you're directly talking and communicating to other computers that are out on that network. Anything you want to add there, Taylor?
No, that's a great example. I didn't even think about that. Yesterday when we were talking about peer-to-peer, I gave the NASA Deep Space Network concept where they had the web of satellites that they've launched into space, and they use each other as routing points to communicate back to our ground stations here on Earth.
Yeah.
So they use point-to-point protocols or peer-to-peer.
That's a good point too. So think about it. The difference between something like a LAN and a peer-to-peer is a LAN is going to be, it's going to have some type of central point where everything is communicating to. That's what a router is. So everything will go potentially to that center point and then out to talk to someone else. But a peer-to-peer is going to go from, I want to go to Taylor's server in his house. If I try to go there on a peer-to-peer network, my computer may reach out to Billy Bob's computer, who reaches out to Jesse's computer, who reaches out to Jose's computer, which then goes to Taylor's computer. I have to go through potentially all the different peers on the network in order to get to where I want. That's why it's, I give the example of like anarchist groups or people that are anti-establishment, because it allows you to create a internet that is based off of the community and it's not reliant on traditional methods of communication. The issue there is, though, going peer-to-peer again means that you're going to a bunch of other people's computers and your data is hitting a lot of different people. So it kind of ruins some of the aspects of the privacy notion that a lot of people raise in regards to that. Let us see here. So, and is there anything here I want to mention? I guess no. We'll just move forward to client server networks. So this is usually when there is a central server which allows computers to log on. The central server can provide various services, including centrally routing internet access, emails, files, etc., etc. Let's see. If we go on this and we grab it and we Google it, again, this is just showing you guys, this is a little bit different than what we've been doing, but this is kind of showing you guys if you need to learn about these concepts, you can copy them, paste them, look in here, And Wikipedia will usually do you good. It will usually tell you everything that you need right here. But effectively, there is one main server that allows for all the clients, aka your normal users, your phones, your computer, your laptop, etc., to then communicate with each other. Anything you want to add there, Taylor?
So first I want to hit on the Googling concept. Programming and computer science is a vast skill set. So if you guys think that we've memorized everything here, absolutely not. We do research. Like, every day when I'm programming, I go look up the documentation, or just Google search what I'm doing wrong, because I make mistakes all the time. I don't have a clue what I'm doing over half the time. But for client-server communication, I mean, this is the pinnacle of networking right here. This is the backbone. Every time you go onto Facebook and you want to get data from Facebook, you're communicating with their servers, and you are a client to them. Just as you are like when you're at a restaurant and you are the client sitting there asking the server for, your meal. You're telling them what you want, and then they serve it back to you.
Yep, exactly. Googling is a very valuable skill. You should know these concepts. You should be able to look back at them and know them at any given point, or at least a high level. And if you were able to then refresh yourself on them, you will know it. But the big thing is just knowing they exist, knowing they are things that exist, knowing that there is a LAN and a WAN. One is for your local house, effectively, or if you're in a building where there's lots of businesses, there will be a bunch of LANs in there. When you want to talk to over the network, you're going to need a network adapter. When you communicate with other computers, they're going to be using protocols, right? Because you can't just talk over each other. The main protocol used is going to be TCP/IP, and we'll get into that more here in a bit. Peer-to-peer isn't really used too often, but that is communicating with potentially a bunch of other people on the network, going to each individual peer to get where you want. Client-server are terms that you should also get familiar with. Client is always usually referring to a user. So you yourself, it might be the user, or maybe you're making software for a user. And then server is going to be whatever clients are usually reaching out to in order to obtain data. All right, any questions on that? So, if there are no questions, go and feel free to ask your questions, and then we're going to get into these network topologies. So, this is all dandy and stuff, but you have a bunch of cable lying around, and you want to plug in these cables into other computers and then get them to talk, go, do the things. How should you plug in everything? What configuration should I plug in everything? Should I plug in my phone directly to my computer? Should there be a middleman? Should there just be one main line that everything connects into immediately and talks over? And depending on what you want to do, different topologies might be the right solution. Also, some typologies work not just for networking in the sense of sending data to different computers, but on an actual physical scale, like on your motherboard. These will be ways you can network to other parts of or other components on your actual computer, and we'll get into that here in 2 seconds when we talk about bus topology. So let's go ahead and copy this, and we'll say bus network topology. So this is when you have a bus, aka a main central line, a trunk line, whatever you want to call it. It's usually called a bus, where everything connects to. So you can see, all these pictures is pretty much the same. There's a bunch of devices that are connecting to a cable, and anyone can say anything on the cable at any time. And since everyone is on the cable, whenever I say something on the cable, it's immediately sent to everyone else that is connected to that cable. So there's not very much privacy, because every time anyone sends any type of data, it's immediately broadcasts to everyone else on the network. Now, the main issue with this is that, again, you're having to deal with potentially a lot of people yelling at the same time, which means you have to then handle things one by one. You can't shout over each other, so there's major slowdowns there. You know, if computer A over here, let's copy this image and pull up Paint. If computer A over here wants to talk to computer B over here, you basically have to tell everyone else, shut up, silence, we're going to talk, everyone be quiet, which means that no one else is communicating at any given point. So data is sent across to these guys, and who knows, maybe they take a second to talk, maybe they take an hour to talk. You could potentially freeze up the entire network because no one can communicate or talk to each other since they're blocking the entire bus. All right, this isn't used as much anymore in actual computer networking, but you'll see this used all the time at a hardware level when you tie components together, like your CPU, your GPU, your memory. This is how they'll typically talk, and that's why they're usually referred to as buses on your motherboard, because they're set up in this type of configuration where everything is, you know, able to send data across the hardware at any given point, and they have their own ways that they communicate and talk to each other, but this is the bus topology. Any questions here? All right, let's move on forward. If you do have questions, feel free to ask at any time. Next, we got a star typology. So this might also look kind of familiar, but effectively you have some type of star. It doesn't have to be, you know, 5 pieces of hardware. It could be 4 or 2 or a million. But it's basically a spoke and hub distribution paradigm. Fancy words right there, in computer networks. All right, so spoke and hub in the sense that you have a hub in the center and then spokes are shooting out the side right here. Pull up my notes here. So effectively your hub will act like the central point of cabling for all of your devices. So everything has to go to the hub in order to communicate with anything else, right? The big advantage for this is it helps with the weird hang time potentially that the bus might have, because the bus, you know, if 2 people are talking, they can talk forever long they want potentially. But with the star typology, you're going to have the hub, which is effectively going to be able to dictate or police when people are allowed to talk, maybe how long they're allowed to talk for in order to respect everyone else. It's just a little bit of like middleman management effectively. So it's very useful, and it's used potentially, it's used all the time. All right, the only big thing, the big issue is it has a single point of failure potentially, and that is if the hub in the center ever goes down, then everything else is dead. It can't communicate. All right. This is pretty much what you have in most of your houses when you have a LAN. You have that router. Now your router might have Wi-Fi, which your phones are communicating on, and you have computers that might be hooked into it, and that is your sole point of failure potentially. But you have a star typography where everything communicates to that router, and then the router dictates who can talk when. Any questions on that? Taylor, anything you want to add there?
So this concept comes up quite a lot in networking because a lot of our smaller end networks follow something like this, like your home network where you have one router and you have all of these devices coming off of it and they communicate through it. So, you know, like you guys saw my server rack behind me, that's an air gap network behind me, and it's sitting in a star topology because there's one switch that's sitting there doing all the routing for all of my servers, the 4 servers that are in there. it's a really simplistic setup. So you just plug and play basically, and it just works out of the box. You don't have to set up any like fancy rules or like you don't have to set up any protocols for like a bus topology, who gets priority and whatnot. You just let the switch handle that.
Yeah, fancy word there for air gap, but effectively means you're not connected to the internet. You're off the grid. You're all alone in the wild. Let me check chat here, make sure there's no questions. We'll get every time to recall these terms, what they mean, and how they all work together. Yes, it will get easier over time. The big thing is for bus, you could literally think of a bus itself and how it's shaped. That's kind of the shape for the bus topology, and everything has to basically get on the bus to go somewhere else, and there might be other people on the bus that like block your way, and so you have to kind of wait for those people to get off the bus first. So that kind of shows you the downfall too, if you want to think of it that way. Star is what you have pretty much in your house. All right, now let's get on to ring. Ring, ring, ring. Not like your doorbell ring. But ring is in the shape of a ring. Go figure. Who would have thought that? But basically, the cabling starts with one computer and then it goes to the next, and so forth and so forth. It's basically peer-to-peer. So this would be a great example of peer-to-peer. I don't really like these pictures. I think these pictures are pretty improper because this is more like a bus, to be honest. But these ones I like better because you're connecting to other computers, and you have to go through other computers to get to the next person. So again, let me copy this image and pull up this. Let's go ahead and erase and make this guy bigger. All right, sweet. So if I am on computer A over here, and I want to talk to computer B, it's a peer-to-peer network. So I have to send my traffic to this guy, who can see everything. I mean, sure, you can encrypt it and stuff, but they have your data. And then you have to send it here in order to communicate. And if this person wants to communicate back with you, you'll have to send it to this person, who then has to send it back to this. Now, there sure might be use cases for it, but in general, you won't really see this too often. All right, there is a standard for ring, specifically in regards to token ring. Let's bring up that one. Token ring, pretty similar to actual ring. So this is where you're going to be using more of a middle man for your communication. This you'll potentially see more often, especially in actual server. What do you call them? Oh, help me, Taylor. Cloud environments, but not in server farm environments. Whew, that was a rough one. You got it. You could potentially see this in server farm environments where you need to connect lots of computers to each other before potentially connecting to a star network where things are filtered out to the internet. You can have different topologies mixed in with other topologies. That is okay. And there is an IEEE standard for this. Let's see, is this I believe this is the one right here. So IEEE 802.5 is going to be your standard for when you're working with token ring. So this is basically what people will be following in order to communicate properly in regards to this. Anything you want to add specifically on this, Taylor?
No, I think you hit that pretty well.
Yeah, but this is for the most part. I'm not a super big hardware person, so this I believe isn't really used too often anymore. Again, star is pretty much king because it's very versatile. Let me go. So again, let's review on everything we've gone over. Bus. Think of a bus, right? How it's thin and long, right? And you're trying to talk to someone else on the other side of the bus. You're going to bump into other people, all right? Everyone is communicating on the same line, and the downfall there is potentially you could be running into other people, so you kind of have to wait until other people move out of your way, which could take a second. It could take 100 seconds. Who knows? Star is the most common one, where you're going to potentially have, or every person in their home was going to have a router and everyone connects to it. All right. Ring and token ring, both in the shape of a ring. Ring is going to be more peer-to-peer. Token is going to typically have some type of like middleman that's going to be handling the traffic, but it will still be in a ring shape, right? Then there's going to be mesh networks, right? Now, mesh networks are something that you will see. That's kind of how a lot of the internet is connected, usually in the internet and business buildings, because we'll get into this example in a second. Let me pull up mesh networks so you can kind of see it. So there's a couple different types of mesh networks. I mean, this should look pretty familiar. This is like the generic, oh, things are connected, the internet images, right? This is not really how most of the internet is connected. There are two variations of it. There's the partial mesh, all right, which at least two of every computer that's connected will have like two connections at a minimum to something else. And then there's the full mesh, which is everything is connected to everything else, right? Not as common to see the full mesh, but the partial mesh you will see more often. When will you see the partial mesh? Well, let's think about something that's very, very important in the real world. Money. You like money? I like money, all right? I have a habit of losing it all, especially, doing stuff like nonprofit stuff, just giving it all away. So, not that great with it, but, money. Very important. It would be a shame if one day you couldn't access your bank account. It would be very painful if you were participating in the stock market and then you couldn't do anything with the stocks anymore. This does happen time to time, but mesh networks kind of help solve this in the sense that it's not uncommon to see in server farms or big corporate enterprises that are running servers. Server farms is in reference to running a lot of servers, or like AWS or something, where they'll have multiple connections going into their servers or their server farms. So what I mean by that is, you might be familiar with, I don't know, like Xfinity. You guys have Xfinity where you are, Comcast, and then maybe Verizon, or you have, what are some of the other big ones, Taylor? I'm blanking on them right now.
We have like Cox Media.
Cox, yeah. There's a bunch of them. There's Google Fiber, all right? You want to make sure your network is really reliable. So not only do you pay for Xfinity going to your house, you may be paying for the Cox network or Google Fiber. You could be paying for every internet provider that's available to you to be hooking up lines to your house or to your business to provide you internet. So if for some reason one of them go down, you still have potentially multiple other options to send your network traffic over. So this is really good for redundancy. And this is something that you'll also see in a lot of crypto networks now. It's very popular in there. They usually run some type of mesh topology. Usually, I think most of them actually run fully connected. Where a lot of them, do they run fully connected? I'm not sure.
They'd probably like to. It's probably close to.
Yeah, don't quote me on any of this. But effectively, the thing is, they're all these nodes are talking to each other to verify the state of the network at any time. And they all have connections to each other. They're all aware of each other that are, at any given time, right? And if any one of the nodes ever go down, it doesn't matter because you'll have at least one if you're doing a partial mesh, because you need at least 2 connections. So if one goes down, you'll still be safe. Your stuff will still be up. It will still be live. It's basically resilience. Mesh is the best of everything. Ideally, the internet would be mesh, but it's expensive. There's a lot of connections. When you have billions of people on the planet that need to talk to each other, it's really expensive. So it's better not to have mesh or even partial mesh, because it's just expensive to lay all that copper, the cabling down and connect everyone. But if everything was mesh, everyone would be connected to everyone at any time. And when things like warfare go on, like cyber warfare, for example, and countries try to shut down other countries' internet, it's pretty common to do that now because there's only a couple main entry points for different countries communicating each other. But if there was a mesh, it would be super robust and it would be pretty much impossible to shut down a country's internet access. Any questions on that? So, review, mesh. I saw the vacuum, I was confused for a second, or the sander there. Where is it here? Mesh. You can have a partial mesh or a full mesh in a mesh network. A mesh network requires at least you to be connected to 2 other people, right? A full mesh, you're connected to everyone else on the network. So if you add a new person, everyone needs to connect to that person now, and more networks get set up, all right? This is also, full mesh is what you get in a lot of machine learning applications. So this is also another important thing to know for that. Any questions on that? So, we're going to go on break before we hit on these next 2 items, but just remind you guys, we still got to pull some names. We still got to do the giveaway, which we're going to do at the end of today's session, all right? So make sure you stick around. We will be emailing the winners, all right? So that'll be fun to do at the end of this. But if there are no other questions, we're going to go ahead and go on like a 5-ish minute break, 3 minutes, 5 minutes, I don't know. We're going to go on a short break, and feel free to ask any questions that you have. I'm watching the chats right now, and we'll go over them when we come back. All right? Whoops, my bad. Sorry about that. So again, what I was saying was networking is important, and we're gonna do something fun right now. I'm gonna have you guys download a program called Wireshark. All right, and this basically is a program that will allow you to view internet traffic that your computer is sending over the network. I'm gonna go and plug this into the chat. There we go. So you guys can go on here and go and click on download, and oh, it's right here. Go and download the one that's appropriate for your device. So for most of you guys, it will just be the 64-bit Windows installer. Go ahead and install that, and I'm gonna just chat while you guys are doing that, because it might take a little bit. We'll get into this more and more, and we'll do more and more examples of it, but it is an application that allows you to view your traffic. Now, depending on where you are and how your network is potentially set up, you may be able to view just your traffic, or maybe everyone's traffic on your local internet, or if you were, let's say, Xfinity, Comcast, a VPN provider, you could view everyone's traffic that's going across your network, or particularly whatever nodes you're on and you're on and analyzing. So this is going to be fun for y'all to look at. I already got it updated before this, so I'll go ahead and pop that one open. It's going to ask for a bunch of permissions. Oh, here it goes again. Nah, gosh. Why? It brings up this box like 7 times for me. I gotta click on it again. Click on it again. Why? Why are you doing this to me? There we go. Why it does that? Because it needs a lot of permissions in order to analyze the traffic, because you don't want just anyone looking at your traffic. So it requires a lot of perms on your Windows device in order to actually look at those the sources of traffic. So while you guys are downloading and installing that, we're going over a lot of the fundamentals, just how things are connected. We're going to be talking about wires and just the actual hardware bits before we get into the actual looking at network traffic part. This is important to know because if you're building software, you know, whether it's just on a server, or maybe you're working at SpaceX and doing, you know, satellite communications, or something more local or something more lightweight, you need to know what type of network you're going to be potentially working on and how you should be sending traffic across that network in order to have it most optimized, because you can't just do anything everywhere at any time, because it may not be most optimal, especially if you have very lightweight hardware. There's something I wanted to mention specifically, which was VPNs. This is where I plug in and say that I hate VPNs. Don't buy into most of the VPN bullcrap that's out there. NordVPN, those other VPNs out there, providers. Most of them are untrustworthy and scams on what they're trying to sell you. Yeah, you can use them as a proxy server, which is what most people use them as in order to watch your Netflix somewhere else. But you're not hiding your internet traffic. It is a lie that they are telling you that it is doing. It is not hiding you from your ISP. Your ISPs can still see everything you are sending. It is going to be... Let's bring up. I gotta do this tangent. I get irritated every time I see the VPN stuff. All right, and then we'll talk about the actual usage of VPNs. So basically, here you are. All right, you look super cool. All right, little stick man here. All right, or maybe you're one of the few females watching, so stick woman. All right. And you have your cool little computer. I'm just going to draw a box for your computer. And here is your internet provider, your evil ISP that's so evil, right? Do I select all the components to install? Yeah, just install all of the options that it allows you to, or whatever the default ones are selected. So normally, let's say here's your ISP, which will have routers that you route through, and then here is, I don't know, Netflix that you're trying to watch. I'm just gonna do Netflix. All right. Normally, you will go out to the ISP. There might be multiple routers that your traffic will go across, and then you'll connect to Netflix. All right. Sweet. All of your traffic is viewable by the ISP. When you have something like NordVM, VPN, or another VPN service, it is mostly a scam on everything they try to sell you on, all right? There is a practical use to VPNs. What they sell you on is impractical, and most of it is bordering on lies or literally straight up lies. Your VPN provider will have their own computer. All right? Here's Mr. Nord at NordVPN. They have their own computer, their own server. What they're going to do is your network is going to be doubly encrypted, let's say, because normally when you talk to something like Netflix, you'll see right here, you'll have this little lock. This means your traffic is encrypted. When I talk to GitHub and get their information from the site, which you'll see here in a second when we go to Wireshark, it is encrypted. No one can really read what I'm doing. They can't read your passwords, etc., unless they're able to decrypt it, right? So what's happening is it's encrypted by default. When you have a VPN, it will do another layer of encryption on top of that, and then your network traffic is going to go to Mr. NordVPN over here, right? NordVPN. All right? Then once it gets to Mr. NordVPN and you got your 2 times encryption traffic, we're back into ISP land over here. I'm gonna do I'm gonna do red because people think that their ISPs are super evil. So we're gonna do red. Everything in here is your ISP, so your internet provider, Comcast, whatever you have. All right. Once it gets to Nord, let me go back to black here. Once you get to Nord, that 2 times like doubly encrypted, super safe traffic that you have will be decrypted. So now it will just be your normal internet traffic. And then it will go back out onto the normal internet and connect to Netflix. So it's a complete waste of your time. It's a complete waste of your money. It's a complete scam to literally almost everyone that's using these providers, because it's not providing you any type of extra security. It's actually potentially making you more vulnerable, because now not only is your traffic just traversing over your ISP, let's say Comcast, now it's also being intercepted by NordVPN. They are able to intercept and get all of your traffic, and then it's going back out to your ISP again. So now you're not just giving your internet traffic to one person, but you're giving it to 2 people, right? So, and then it goes, and it's not even doubly encrypted anymore. It's just the normal encryption that you have, and you access Netflix. The big thing is the servers over here, you know, maybe this is their USA server. You know, again, this is just, again, servers are just computers. They're like the computer you have in front of you. Maybe this is the US one. They'll set up another server in, I don't know, let's say Japan, because you are into anime and you want to see all of the latest anime stuff, because that's something a lot of people that are using Nord or VPN services will push. I use Nord as the example because they're the biggest advertiser in the space. All right, Mr. Nord over here will have another computer over in Japan, physically located there, all right? And effectively, all your traffic will go to the Japan one, and then it will be unencrypted and sent back over the ISP to where you want to go. It's a complete waste of money and resources for you. Do not do it. unless you're just that desperate. But when we finish this, you should be comparable enough just to stand up your own proxy server or VPN yourself, because they're very easy to stand up, and they're very cheap just to rent yourself. If you run stuff on AWS, aka Amazon's hosting stuff, it's free they have a free tier, and you can do it for free. All right, do not do it. It is not worth your time. All right. Are there any questions on that? So we'll go over the actual real world why VPNs were created in the first place and the real world usage of them. So Wireshark is designed to be used with Windows. I have Chrome OS. Okay, yeah, if you have Chrome OS, it's okay. I'm gonna show off examples, and you'll be able to view from there. Wireshark is not a requirement that you need it installed in order to pass the exam or anything like that. It's just a nicety for you to have in order for analyzing. For Chrome OS, I don't know, but don't worry about it too much. You can just view the network traffic I'm going to show off on my Wireshark. But at the end of the day, they're scams. Stay away from them. Tell people not to do them. It's a waste of money. All right. A lot of them, the more sketchier ones, I've looked into Nord, and their verbiage seems to be more correct. They seem to be one of the more ethical ones. But again, if it wasn't Nord and some other VPN provider that's out there advertising, all of your data is going to them. They can see where you are trying to get to, where you're trying to go, what sites you're trying to go to. They're collecting that data, analyzing it, and usually they are selling it. They are selling it to governments. They're selling it to corporations that want to get analytics on you. Right? Do not do it. It is no bueno. It's not worth it. All right. The actual usage of VPNs, which this is hopping forward a little bit, is, oh no, let me do new. Don't save. So again, we talked about this thing called LANs. All right. Before I go forward, Taylor, is there anything you want to add?
No, I think you killed that point.
All right, perfect. It just really irritates me when I see these ads, and I see them all of the time, and they make so much money off of it, and it just irritates me because they're whatever. We're gonna move on. You have your LAN, which again is like you at your house or your apartment or wherever you are, right? And at your house, you'll have your little router, all right? This house is not big enough, so just imagine like this whole area is your house, right? In your house, you have your router, all right? And then you may have your phone. I'll just put a circle here. Maybe you have, I don't know, your laptop and an actual computer, whatever. Let's do this as like an actual computer. And all of them will talk to your router. And then that will go out to the internet. All right, WAN. We have the internet. Internet. I bet you guys missed my beautiful drawings here and my beautiful... Did I even spell that right? I don't know. We're moving forward. Who cares? Now, let's say you have a cool server here. So you have your cool Minecraft server. All right? Now, your Minecraft server, you're doing some important work on it. You don't want it exposed to the public internet because you are making the latest, greatest mod for your Minecraft server. Or maybe you're making a brand new game. Or maybe you're an actual company. So instead of this being your house, you're an actual business that is running some internal services that you don't want publicly exposed. Maybe there are databases. Maybe you're Google, and inside of Google's internal networks, they have databases that store users' information, all right? This is the picture that's usually used for databases, all right? Maybe there's just important things that you don't want exposed to the internet, all right? They're only supposed to be accessible to people that are within your local network, aka an arm's reach of you. But you have remote workers. That's a big thing right now. All right, I'm going to use that as the big example. Let's say you got Joe over here. All right, and Joe is your remote worker, or maybe your friend or employee that you have. I don't know. Joe can be whoever you want. All right, and Joe lives in Timbuktu. All right, Joe lives in Timbuktu, somewhere else, 10 miles away, 100 miles away, a million miles away. It does not matter. He lives somewhere else, and he's in his own little house, in his own little land. And you want him to be able to communicate to your server. But your server, you don't want it publicly exposed, or your database, you don't want it publicly exposed to the internet, because that would be a huge vulnerability. You could leak a lot of information. So what VPNs are meant for is you over here will set up a VPN that will allow for Joe to act as if he's inside of your local network, as if he's actually in your house. All right, that's what it's meant for. That's its actual purpose. It's meant for emulating someone that is not actually in physical range of your LAN, all right, and tricking the system basically into believing that he's actually there. And then he will be able to access directly the server or the database that's not publicly exposed on the internet. All right, and when you send this type of sensitive information back, a lot of times maybe it's not even encrypted in the first place. So that's why it will be potentially doubly encrypted or just singly encrypted back, because if it's not encrypted in the first place, when you get the data back, you want that data to be encrypted because it's sensitive. So that's what VPNs are meant for. They're meant for literally corporate entities, businesses that want to have things that are of sensitive value, but also have employees be able to access them without showing up physically to the office potentially. All right, that is what they are meant for. Most people use them as a proxy server, which is basically a server that you will forcibly route your traffic through and act like it's coming from, in order to emulate you being somewhere that you're not, like you live in Russia or something. All right. Okay, any questions there on VPNs? We'll hit VPNs a little bit more later, but I just had to go on that side tangent because it just really irritates me. Any questions? As questions may or may not roll in, let's go ahead and look at Wireshark here. So I have a lot of, you'll see here showing up at the bottom in this thing called Capture. You'll see these live graphs come in, and this is basically the internet traffic that you're participating on right now. You will not have what I have here. I have a lot of stuff here because I'm running VMs and a bunch of other stuff. What you will have is one cold loopback address, which we'll get into that later. Don't worry. It's pretty much you being able to talk to yourself, right? And then you'll either have Ethernet or wireless adapter or something wireless. I have an Ethernet connection, so I have a physical cable plugged into my computer, but you may be on a laptop or something that's communicating over the internet. That is the thing you want to click on, right? Because we want to look at this traffic that's going over this connection right now. All right, so if I double click on that and I click on accept, you will see right here that I have live traffic. This is real data that's being sent to my computer, all right, across the internet, maybe on my local computer. I'm going to go and click on this button right here for stopping because I don't want this to keep loading up more and more data. But this is live data that's being sent across the wire. And we'll be getting into this more and more as we go forward. But you can see by default when we click on, like this. This is data. This is me going to some website. We'll figure out how to, we'll go over how to reverse engineer and figure out what site or website I am talking to right here. But this is your data. This is the encrypted data that's being sent across the network. At least I believe this one is encrypted. I'm pretty sure this one's encrypted. Usually it will have, yeah, this, but you can see right here, all your data is fully encrypted. There's nothing, you know, this is website data, website traffic, and we're not seeing the actual data from the website being sent across. And we'll see what encrypted, or we're already looking at encrypted, but we'll see what unencrypted data looks like when you're looking at it in Wireshark. All right. But this is a really good tool for learning, testing, and going over all of the things in the networking world. And you can see here's our IP. So IPv4, that's what we're using right here. We'll get into that more. And then here's TCP. So this might look a little familiar. Transmission Control Protocol is TCP, and IP is Internet Protocol, aka your IP addresses, something you might hear used as a buzzword a lot. So this is the TCP IP. This is how I'm communicating right now. This is not the only way you can communicate, but it's the most common and popular way you can communicate over the internet. All right. Any questions on this? Does everyone have that is able to install Wireshark, able to launch it fully and see traffic come across? If you aren't able to install Wireshark, again, don't worry. We'll give all the examples we'll visually show. Just checking the chats here. Perfect. So let's talk about hybrid topology. All right. Something that is very, very common because it's hybrid, which you've seen pros and cons of each of them, and they have lots of pros, lots of cons. But the best thing is, let's just put everything together that we like when we need it, and bam, that's hybrid. Hybrid is literally everything combined together using two or more different topologies. All right. So mixing everything together and using it in effective fashion. That is how the modern internet works. All right. It's hybrid. So we're plugging, we might be using Star in our local network. We might be using like a partial mesh at the ISP level. You know, it doesn't really matter. Hybrid allows you to do whatever you want, wherever you see it fit. Any questions on that? The big thing for hybrid, let me see if it even brings it up in here. God, I don't want this. Where's my nice little Wikipedia article at? Well, the big thing is there's usually going to be core components, sometimes called the bus. So here's one right here. Well, this is about the bus network. But there will be core components that will connect everything else together. All right, that typically is called the backbone, or like your ISPs, the backbone of your internet. Let's check the chat. Looks like everyone's good. So again, takeaways, hybrid, meshing of everything together, and usually you'll have something that is central, or that is basically the glue that is able to glue all of these together. Those are going to be called the backbone of your network, the backbone servers, the backbone whatever. It's the backbone of your network. Any questions on that? Taylor, do you want to add anything?
No. Not this time.
All right, sweet. So let's talk about the very last one here. Point to multi-point. So point to multi-point means that there is one central point that can communicate with a bunch of other people at the, potentially the same time. This is different than star, because it's usually in reference to wireless stuff, like cell phone towers. You have one central point that connects a bunch of devices together. All right, does that make sense? Or maybe you're using Starlink. There's satellite internet, and they're beaming it down from up above. One satellite, a bunch of people below. That's going to be your point to potentially multiple other points. Usually the multi-point, let me reread the definition here, but usually the multi-points that it's connecting to will be other potentially big providers. So for example, Starlink will be a point that's connecting to potentially cell networks. So if you guys don't know, the satellite will connect down to other servers or cell networks down below, and that's how they kind of get your data across, is backboning off of the cell networks. And so that's more, I believe, keen to multi-point, is you're connecting to, let me just read this here. Consists of multiple devices connecting to a single device to communicate. Multi-point and star typology look similar but work differently. In star, the central hub is the relay point for two computers. And in multi-point, computers on the network communicate to a central device, but not with one another. All right, that's the big difference, is the one another. So on a star network, all right, that's like your house. Let me pull it up here. New, don't save. So you got your big house here, which is going to be following star. Beautiful house. You have your router, and you have your phone, your computer, whatever other devices have, and you have the internet. Your star here, everything communicates with the central hub. That central hub may go out, but you also have the option of directly talking to other computers on your network. So if you're hosting a server in star, you can talk to other devices there. But on point to multi-point, if we have, let's say, a cell phone tower, this is a beautiful cell phone tower, okay? And you have lots of, I guess I should just use this. You have lots of phones everywhere. You don't really want these phones having the capability of talking to each other directly. That could potentially cause problems. People can mess with other people. So point to multi-point requires all of these devices to talk to this central hub, essentially. They can only talk to this guy in the center, and this guy in the center then can connect you to the great internet. All right, any questions on that? So let's go over this again. TCP/IP is the way that modern computers will talk to each other by default. It is the de facto standard, all right, for most communications, all right? By most, I mean like literally almost all of it, but we'll get into examples here where it's not used, or other things are used instead. Protocols, basically just the rules of how you communicate each other or how you dress each other. It's the customs, courtesies, etc. Network adapter, that's going to be how you communicate to the network. My phone has several network adapters. I have the cell adapter, aka the cell antenna, where I can talk to the cell towers. I have Wi-Fi, so I can talk to Wi-Fi. There's even Bluetooth in there. All right. There are multiple network adapters in this. Your computer may only have one or two. Mine only has one. It's an Ethernet connection. All right. You have your local area networks, which is going to be everything pretty much in, you can think of it in arm lengths of view. So everything that's in a local area that has the potential to talk to each other, but isn't connected to the broader internet, like openly connected to the internet. You might be able to go out to it, but you're not a part of the open internet and like servers that are being hosted. The big discernment there is there will be some type of router that will be the central hub for the local network. Wide area network is going to be the internet. Peer-to-peer is you going and hopping peer-to-peer to connect to someone. So you going from yourself to Bobby Joe to Sue and then to Taylor because you want to talk to Taylor. Client server, you an individual or multiple individuals trying to connect to a central server to maybe view the website. All right. Then we got our hubs. Bus. Think about a bus, an actual physical bus. Long, narrow, a lot of people on the bus, crowded bus. You can't really easily talk to your friend in the back, which would be like another computer per se, when there's a bunch of other people moving around at the same time. And you don't know potentially how long each other will be talking to, someone will be talking to each other, or things will be crowded. So it's really inefficient sometimes when you're trying to communicate. Star is the most typical one for LANs. That's where you have some type of router that you are connecting to, your Wi-Fi point or whatever that you're connecting to. All right. You also have the option to connect to directly to other devices on the local network if you want. Ring. It's a ring, kind of like peer-to-peer. You have to go one after the other. Token. It is also a ring, but there are some middleman items that you can utilize. Mesh has two states it can be in, a partial or a full. It requires to have at least two connections to other items on the network, right? Full mesh, you are connected to every other thing, and every other thing on the network is connected to every other thing, all right? It requires lots and lots of connections. It can become very inefficient very quickly. Hybrid. Mash whatever you want together, right? You have to be using at least two of the other topologies, all right? And then point to multi-point, think of your cell phone towers and your satellite internet, right? Any questions on any of those guys?
I would just like to add a little bit of context.
Yeah, go ahead.
So, in the real world, like when we're building out these massive networks, like even for our rootkit network, we have multiple layers, multiple different types of networks with people, like student networks, we have our teacher networks, we have our administration networks, and all these different types of networks with different devices in them and different purposes and control mechanisms. None of them are strictly any of these. Well, I guess the hybrid, because, you know, an amalgamation of a bunch of different types of networks to fit the need of the underlying requirements. So we're talking about these things as if they're absolutes because we're talking about the theory and we're boiling it down to simplicity's sake. But in reality, you're going to see these all just mashed together to solve whatever problem you're solving at the time.
Yep. No, I like that. And I mean, more so in the sense of you have different friend groups, and different friend groups communicate to each other. Maybe it's literally a friend circle group where you guys all meet up and you talk to each other. That might be more appropriate to a mesh. And then there's might be other connections where you have where it's like a friend of a friend that you can communicate to. That'd be more like a peer, you know. Just like there's different actual networking groups in real life, there are networking groups in computers. And hint hint, a lot of things that you'll see in regards to the computer world, especially in the networking areas, they're copying a lot of real world phenomenons, like real world things that happen naturally when we talk to each other and network and communicate, because it's a great example. It works for us. Why wouldn't it work for a computer? Any other questions there? And if not, we'll get ready to pull some names for the giveaway. Any questions at all? Any questions from the hardware section that you guys went over with Taylor. Anything that you want to add on, Taylor?
No, I guess the one thing that I would like to add on is the fact that, as we see here, a lot of these concepts we talked about at a hardware level of like having our bus where we have our devices and we have our bridges, our north and our south bridge. Those are kind of like the routers here in the networking sphere. So a lot of these concepts, like Elijah said, carry over from real world experiences, such as like the US postage system. All of our networking technologies kind of mirror real life things like how, USPS handles mail. Or UPS, yeah, UPS handles mail. We have to sign everything. You have to put the address onto where it goes. You have to have a return address for them to send letters back. All of those concepts come into play here at the hardware level and networking level.
I like that. Yeah, because I mean, at the end of the day, it's just you trying to solve a simple problem. How do you communicate between point A to point B? And in an efficient manner, because you don't want to wait forever. But it's the same thing with, like he said, with the mail system. How do you send mail from point A to point B? And you want to do it in an efficient manner because time is money. You don't want to waste time because then you're accruing extra costs. You're being less efficient. You want to be as efficient as possible. Any other questions, you guys? All right. Go and ask your questions. This is the last that you have. So tomorrow is going to be our chill day. We're going to kick back, relax. We're going to just be here to answer questions, go over anything that you guys want to go over, particularly from any of the previous lessons that existed. Maybe something wasn't covered well enough for you or didn't make sense. We can go over it again. All right. It is going to be as long as you want or as short as you want. It could be 10, 20, 30 minutes tomorrow. It could be the full 3 hours. It's totally up to you guys on what you want to ask questions about. And it can be from anything from what we've covered so far all the way back to the beginning. But that's what tomorrow is for. All right, so no other questions. So let's get into this raffle. Let me log on to the site. WP admin. And taking forever to log in. Here we go. And let's bring up the raffle. So first thing we're going to do is we're going to rerun the raffle from last week because the 3 individuals that were picked did not respond. So again, covering this, we will pull names. The names that we pull, we will announce the names here. We are not going to show the email addresses or anything on stream because we don't want to give people's information away. But it is an actual automated system where I click and I say how many people and will automatically choose them. We will email you if you did win. All right, you have 1 week to respond. If you do not respond in that 1 week, we are going to re-roll again at the end of the week. So on week 3's giveaway, because we're doing week 1 and 2. We're doing week 1 re-rolls and week 2 giveaway. Any questions on how that works? Let's go ahead and get into this. All right. So let's roll for week 1. And we have Jamie Keene, we have Andre Romero, and we have Rakshith S. You guys are our 3 winners from week 1. So those were stickers, and the surprise gift was a pin. All right. So we will be emailing you guys and hopefully sending you guys off your gifts. So let's see about this week. And this week, we are giving away one of these beautiful, beautiful t-shirts, all right? To one of you lovely winners. So let's go ahead and check this. And we're going to draw 1 winner for this week. The mystery item will be one of the exclusive 100 Days of Rootkit stickers, all right? that is the mystery item for this week. So the winner is going to be Mariko Allen. Congratulations, you have won the t-shirt. So we'll be emailing you, all right? And remember, you guys have 1 week to respond. 1 week to respond. If you do not respond, we're going to be re-rolling again. Check your spam, all right? Sometimes they go to spam, so check your spam, all right? Check your spam, check your spam, and check your spam if you don't see it. We're going to be sending out the emails here in like 10, 20 minutes. So they will be there very shortly. All right? Any other questions that people want to ask at all before we end the stream? Awesome, awesome. You guys are awesome. You guys are learning at lightning speeds right now. I'm super impressed. You guys are doing better than me, all right? You guys are learning super awesomely. You guys are soaking in all this information, and you guys are winners, all right? So I guess we'll see you guys on the next one, aka tomorrow. All right, we'll see you guys.